Hi everyone. Today we are going to discuss about data types. Python provides uh, basically the three primitive data types: list, tuple, and dictionaries. Why we need the data types? Um, we have variables and value. Therefore, variable holds values. Uh, Typically, we can have um, this value. In order to use this value, then we need to place that value in this placeholder name. So right hand side, that is the value. Left hand side, that is a variable. Right hand side value can be assigned to the left hand side, that is a variable. So name variable can contain the value Sam Smith. The variable GPA holds the value 3.7. So variable declared with the value, then we can handle the values on our computer. That's fine. Then why do we need the data type, so-called? What if we have multiple values? It's very hard to handle. In order to have, for example, 10 values, then we need to declare 10 variables. What if we have 100 million values to handle? Should we have 100 million variables to declare? It's very hard to remember all of those, very hard to point out which one is what. Therefore, if they are a very similar type, then we can put them in one data type. If we have same kind of data, series of same kind of data, then we need to declare that as a list. Okay, see, this is a list. This list contains a number of names. So you have John, Adam, Brown, Peter, and so on and so forth. So we can define a number of values within one variable. So that variable can point, say here this is name. Okay, name is a list of names. We could have more and more as we declare in this series. Therefore, we know which one's first, which one's the second, which one's the third, which one's the fourth. To point a specific position, we use the index. Index counts from 0. So 0 to 0, 1, 2, 3, 4, 5. So first element in that list can be indexed by index number 0. Second element in the list can be indexed by index number 1. So index number can be 1 smaller than the cardinality of this, the order of this list. So that is a list. So list contains the numerous, the values, if those values are the same kind. On the other hand, we can think of the tuple. Tuple is also a sequence of data, list of data. They look similar, behaves a little different, right? Look similar. So in what case do we need to define a series of values in a list? In what case we use that in tuple? As I said, if those values are the same kind, then put them in the list. If the values are not the same kind, but we know combining all of these, then we can construct one specific objects. Then we can call them in a tuple format. So there is a tuple. So this is one object. So John, number 1, cyber, IoT, whatever that means, that constitute that specific objects. That is a tuple. Okay, those values are not the same kind, but combine all of those, then we can construct one object. There are so many such things, right? Terminal, monitor, keyboard, mouse, number of processors, and memory size, then that can constitute your laptop, right? Then those values can be stored in a tuple format. Tuple and list can be identified by different symbols. List, then we use this square bracket. If there is a tuple, then we use curly braces like this. Oh, I'm sorry, not the curly brace, but parenthesis. For the tuple, parenthesis. For the dictionary, curly brace. So we have series of data can be stored in a list or tuple. In what case can we store the data in a dictionary? If we have a pair of the key and value pairs, then we can call it a dictionary. I'm not sure you guys use real English dictionaries. If you see the English dictionary, then there is a key and value pairs. So you may be able to see the annotation of the given key words. Okay, if we want to look up what mercy, M-E-R-C-Y, means, then you need to look up the key first, and then you can see the value associated with that key. All right. In the case we use a dictionary. So dictionary format is quite different from list or tuples. List or tuples are similar, but implication is different, right? This is the same kind of data list. This is the combination of all the values can constitute a specific objects. Then we can use a tuple. The language, the Python language wise, they are also quite different. So we'll look at that. Dictionary, we'll do that in the next class, but you can see this is pairs of key and values. Within this curly braces, and there is a pair. This is a key, and this is a value. So in between we have colon, key colon value, and there's a delimiter comma. That comma is the delimiter also for the list with the bracket here, for the tuple with the parenthesis, but there is a delimiter comma. That should be the syntax of the defining data types. So we'll look at 3 data types. Today we will look at and hands-on practices for the list and tuples. Next week we'll do dictionaries. Okay, all of this, now we'll do the real the notebook. I wanted to bring up the notebook. Then there is a lab number 2A. There's a list and tuples, which is part of the data types in Python. So next week we'll do lab number 2B, dictionaries. All the rest I wanted to read, but I want to guide you how you can work with this notebook. If you click this, then you can see the list of APIs associated with the list. Click this API, then simply you see this is the data structure list. This list has, for example, this is a list variables, and we have dot notation, and the next one is the function. So function can work with the objects, in this case a list. So whatever the list name dot append, then you can append something into that list. Okay, so that type of things. Exercise 2.1.1, we want to create a list, add more elements to the list, access an element or multiple elements, and add a list to an outer list, etc., etc. So first here, create a list. we can simply type this student equals John, Adam, Chris, and Brown. So this is a variable. All of this right hand side, that is the value in this specific data type. It's not atomic value. But a list of atomic values. So that is the right hand side. That can assign to left hand side, which is the students. So if we, for example, print student, then we may be able to see what it is, right? So I want to stick them together and see. So I have the output, because I said print the students. This Google Notebook is so intelligent, so it gives me something that I want to do that may help you also. So to this students is already formed in the square bracket. Therefore, John element, Chris, Brown, each of these are not just the atomic independent atomic value, but they are together in a list. We can extract the atomic value from there, but right now it is defined as a list. We can add more. If you want to add more, then we need to do to this student. I want to append and Peter, and I want to print to see if Peter is entered into that list. List is a ordered sequence. So which one's first, which one's the second, which one's the third. So when I append, it append to the end of this list. So new value Peter will be the last element in that list. Access a list. If you want to see, for example, print student, what is my first element in the students list? Then you can see there's a John, because John is the first element. If you want to do what is third, what is the index 3? If we say index 3, then it returns fourth element, because index counts from 0, right? Fourth element here, first, second, third, fourth, Brown. So Brown can be returned when we say number 3 index to students. Access an element, a list. Third element we already did. Second last element. How can you get the second last element? We can also do student, and when you enter there, we count from the left end, the first one, then we count from 0, 0, 1, 2, 3, 4. If you want to count from the last back order, then we count from -1, -2, -3. There is no negative zeros. Only 0 can be counted from when we count from the forward order. Okay, it's a back order, then count from -1. So -1 is the last element, -2 is the second last element. If you want to get the second last element, then that will be the -2. What is the second last element in this case? If we look at these code segments, given list contains 4 elements, and we append one more. So at this point, the last element is Peter. Second last element is Brown, right? So we have a Brown there. Oops. Oh, by the way, the index, then we need to put not the parentheses, but we need to put the square bracket. That way we can see, we can point specific position with the index number. Okay. So we have a Brown. This second Brown is from this print. The first Brown comes from this student 3. if we want to access the values in certain range, then you can do that too. Student, the range, then we need to use colon, and then the first position and the last position. If you want to do, for example, access from second element means in index, then that is 1, right? First element can be indexed by 0, second element can be indexed by 1. Fourth ones. So fourth one can be indexed by 3, right? But when we specify here, if we put 3, then this is the language. If we put 3, then it doesn't include 3. It goes up to 3, but exclusive. In order to make it, then we need to put here number 4. When we say number 4, it is not fifth element, but just before the fifth ones, which is the fourth. See what happens. Okay, so this is first, this is second, third, and fourth. So 3 of those can be returned. First, and the second one, therefore index 1. Third one, index 2. Fourth one, index 3. So rather than put here in index 3, we need to put one more, specify one more, therefore we will get one less. It's not really one less. We can say to that number, but exclusively. That number is not included. We want to add the list using extend. When we add a value, then we can use append, right? We can add more student to rather than add. If we have a list into the same level of the element, then we need to extend the method. This extend method should take another list. So put this list. See here, this is a list. List will be added to this list, but I want to get them, this A and B, at the same level of the element that we currently have. Then we need to do extend. So the result will be print student, then we may be able to see it. Here A and B are added to the same level of those. In that case, we need to use extend. In the case of add another list at the same level of those the existing element, then we need to use extend. Similar things if we want to do here append. See the same thing. Let me bring this. Here same thing, but if I want to do rather than this, if I use append, see what happens. If I use append, then I wanted to see the result difference. Here, John, Adam, Chris, Brown, Peter, A, and B, all are at the same level. But when I use append, this argument is exactly the same, right? They are the same arguments. But because I have used different method, above I said extend, here append, therefore this guy is appended as is. Okay, now how many elements in this case? How many elements? 1, 2, 3, 4, 5, 6, 7 elements. So if we want to see the elements, then we need to use the len function, length of that student. And then we have 7 elements. 1, 2, 3, 4, 5, 6, 7. Same thing if we want to do how many? how many elements here, and run. We have 6, right? This is 1 at first element, second element, third element, fourth element, sixth element. This is as a whole. This is sixth element. Okay, 1, 2, 3, 4, 5, 6. Yeah, 6 element together. So we call that nested element, right? Nested list. In that case. How can we access? We can access. The thing is this. Therefore, if we want to print student, and then 1, 2, 3, 4, 5, 6. So 51s. If I want 0, 1, 2, 3, 4, 5. So if I say index 5, then it returns this. What if we want to get specifically this one, this first one? How can we access? We can access it. See the difference? This itself, currently this itself is what? This nested inner list. Within inner list, then we can see the different order, right? Order again. We count again. So this is order 1, the first one, index 0. This is index 1. Therefore, if we want to access A, then that'll be the index 1. Therefore, we can get the first ones. See what happens. See? So to access that one, how to access A in the student list? A is in the sub list, in the inner list. So we have to get to this inner list first, which is up to this index 5. Once we have that inner list, then we need to recount. Therefore, there's a first one. Okay. There's a homework assignments 1. Recall exercise 2.1.2 above this. Use insert to insert append, swap. I want to see the insert and list and then sort. Those are all things that can be found here. Extend, insert. For insertion, you need to use index and the value. For example, if we do here, I want to work on here. Okay, so I want to make here student.insert. Currently, we have here this many. I want to insert C into between A and B. Then I want to first to say the position, and then value itself is C. I want to decide the position here. Okay. This is index 0, 1, 2, 3, 4, 5. So it should be 6th index. 6th index will be the character C. So we need to put 6 there and hit enter, then we'll be able to see that. No, then we can see, I want to see the student itself. So C is in between A and B. That is the insertion. So we can do insert, append, swap those inner lists so that we can have A, B, C. Swap those lists. Okay, swap those two inner lists so that we have this. Oh, I think we need to have these guys needs to be swapped, right? It's not like this. So it'll be like this. Let's see here. Where is it? Inner list needs to be swapped. So this guy's put this here, and this guy push it back. I think that's what it means, right? So inner list should be swapped. So I wanted to think of that. The hint here. Let's say if you want to this, first insert somewhere here, and then and maybe this one insert to the last. So you can use insert. If you want to delete some, then you can delete among those things. Because if you take this and insert over there, then these exact things appear twice. Then you can delete. When you delete, then you need to put delete and some of the list index. And sort is another thing that you can do. So it'll be like this. So ABC comes here, 3, 4, 5. Yeah, that's the homework assignments. Tuple tutorial, also similar things here, tuples. Then you can see here, when you see the list, then list has so many method or functions available. Pop, clear, index, count. Count returns the number of times X appears in the list. So how many times a specific element appears? Can be listed more than once, right? Sort, reverse, copy, those things are already defined with the list. But on the other hand, tuple, if you see tuple, then tuple has there's nothing, right? What do you mean by this? It says tuple is a collection which is ordered but unchangeable. It is not changeable. Once you create an object, you cannot change it. In other words, here, student Adam, name is Adam, 29 years old, cybersecurity, Mercy University. If you want to change this, you cannot change, but you can see it only. You can see it by print all of those. You can access third element by having index 2, then you can see the cybersecurity. You can see it like this. But if you want to try other methods that are available, there's no others. Only what it has is you cannot append, you cannot extend, you cannot do anything. But what you can do, there's one way that you could do. You can change it. You can convert from list to tuple, from tuple to list. Okay. Tuple is very, very limited, unchangeable. But there is a way that you could do if you can convert a tuple to a list. Once you have a list that is converted from a tuple, since list has all kinds of methods that you can use, therefore you can manipulate the element that is converted from a tuple. So you can manipulate all, and finally you can convert back to tuple. Once it is in tuple, unchangeable. Okay. So for example, here print student Adams. Okay, then there's a student Adam. If we want to change this, for example, print, if we want to do append new, say computer science, and then you can also try to see what it is. If you want to do, then it gives an error. Error says tuple object has no attribute to append. Append method is not available. Right? What should you do if you want to do this? Then you need to convert. See here, Adam in list, atom list is nothing but the list of atoms. What it means is that I want to yeah, let's do print. Student atom is, you see here there is a the parenthesis, which means this is a tuple. When I change this to, when I use a list and put this atom tuple as an argument to that list function, then this evaluation result will be a list. See here, that is square bracket. If you want to see the type of those, print type of student atom. And if you want to see print type of atom list, then we need to have one more parenthesis here and hit enter. Then this guy is tuple, and this is a list. Why this comes from the, oh, because I put this there. So this guy is a tuple, that guy is a list. Once we have a list, then we can do, okay, we can do, say here, I would say this is not student atom, but student list. Then you can add that student list, and then you can do print atom list. See here, once student atom is converted to a list, we can append computer science. Right? Once we have that, once we complete that, we can return it back so that we have atom tuple. It's nothing but it comes from atom list to the tuple function, then it'll be a atom tuple. So if we run this, finally it can be a tuple. So original tuple does not allow to add or delete any modifications, but once we convert it to a list, and then after we're done manipulation of that list, which was originally from a tuple, now convert it back to a tuple, then this is a tuple. Once we have that tuple, then atom tuple append math not allowed again, right? Because atom tuple is a tuple formats. Okay, so homework assignment 2 here. Consider a vehicle that is described over register year, make, model, color, fuel, cylinder. There's a tuple like this tuple. How can you make that, for example, my car, this is my car. My car is that, and what did I say here? How can you make this, here we have a fuel and cylinder, fuel and cylinder, but can we have, same my car, could be motor. My car at old definition is an engine, fuel, gasoline car, but my car for new definition, that is maybe electric car, therefore only how many motors in my car. So I wanted to change it to like this, okay? 2021 Toyota Highlander white but motor. Given code is this. This is the today's lecture. I want to do the homeworks, those two homeworks. See here, because these homeworks assignments are embedded in my lecture. If you save this into py, it contains many of those not necessary for your homework assignments. So you have to clean them out. So I want have only your the homework assignments, not others. Okay, if you give me all others, then of course it cannot be graded. It could be errors, so you may not have the full credits or no credits. Okay, this is it for your I think first step in the coding world. So defining a data type, you can extend your data manipulation in your coding a little more and then a little better. So we can do more next week. Thank you so much for listening my lecture. I'll see you next week.